quite a bit of a problem. Now, the solution. Fortunately, Objective-C, like many other OOP languages or object-oriented programming languages, have a feature called inheritance. And what is inheritance? Well, inheritance allows you to base a new class off of a previously created class. So this allows us to have one class with the generic information for all the transactions, and then we have a class for the specific type of transactions, such as cash, credit, and any others that we may have that inherit from that one class with the generic info, and then they put and they have their own specific information for each one. If you've ever made any websites, and I don't mean making them with like iWeb, I mean if you actually made any websites using HTML and you've actually done some website coding, you can kind of relate to inheritance with how you would place the generic page design in one file. So all the stuff that's the same on every page. So like the banner, the menu bar, the sidebar, all the links at the bottom of the page, you'd put all that into one file, and then in the individual web files for each web page, you would put the content that's completely different for each web page. But all the stuff that's the same you'd put in one file, because then if you want to modify, let's say, one link, or if you want to add a new link on the menu bar, you just change it in that one file and it changes it on all your web pages throughout the website. So that's kind of one way that we can use inheritance. Now, some of the basics of inheritance. You need to know what a superclass and a subclass are. Now, a superclass is the original class that you're basing the new class off of, and the subclass is the new class that's based off of the original class. And a subclass is just an extension of the superclass, and I'll get into exactly what all that means a little bit later. Now, how you can remember which one is a superclass and which one is a subclass, how you can kind of tell them apart. Well, the best way is to just think of what super and sub really mean. So super means above, more, over, and then think about that with that diagram down there below. So you see the superclass over top or above the subclass, and then you have the subclasses, and sub means lower, less, below, and then think about that with the diagram and how they are lower or below the superclass. And so if you just think about superclass and subclass in kind of this top-down hierarchy way, it makes it very logical, and it's very easy to remember which one is which. And remember that subclass inherits from the superclass. Now, how are we going to use inheritance? Well, I already touched on this a little bit. What we're going to do in this situation and in most is create a superclass with the common functionality between the, in our case, two classes. And we will create a transaction superclass with the generic information for all the transactions. And then we will create a cash and charge and any other transactions that we might need, subclasses with the unique functionality. And now I'm going to go over a model of our program and of the transaction, the cash transaction, charge transaction. And I'm going to show this diagram or model of the program using the UML, which is the Unified Modeling Language. And this is a very common way for programmers to show models of their program and how everything works together, especially how all the classes work together. So with this, you have a box for each class. You have the name of the class at the top, then you have the ibars in that box in the middle, and then you have the methods in that bottom box. Now, here is the model of our program. At the top, of course, you can see NSObject, and that is there because that is the root of all classes. It has lots of ibars, lots of methods, it has lots of functionality. Now, we have transaction, and transaction, of course, inherits from NSObject, and then transaction declares the ibars budget and amount, and it also declares the method spent. And then you can see that cash transaction and charge transaction, they just inherit those two ibars. They don't declare any new ones. And then you can see that they also have spend. And you may be wondering, well, why are they declaring spend if transaction already declared spend? Well, there's actually common functionality between cash transaction and charge transaction that is in spend. Functionality that is in both of those methods. So you put that common functionality, first you declare the method spend, and then you put that common functionality in the superclass, and then both of these transaction types, so charge transaction and cash transaction, both inherit that common functionality, and then they also specify their specific functionality that is different from each other in their own methods in cash transaction and charge transaction classes. Now, the arrows aren't part of the UML, the Unified Modeling Language. They just show the hierarchy of the class. So you can see transaction is the superclass, and charge transaction and cash transaction are the subclasses. Now, a little bit more on inheritance. You can see that cash and charge inherit everything, IVARs and methods, from its superclass transaction. It's just like every IVAR and method from the superclass is actually implemented in the subclasses. And every class, except NSObject, which is the root of all classes, is really just another step to increasing specialization, because you have NSObject, which has a lot of power but is very kind of generic and general, and then you have transaction, which inherits from NSObject, and it specifies a lot more. It has some specific functionality, and then you go down even more to charge and cash transaction, and they make transaction even more specific. So as you can see, as you go down the hierarchy, you just get more and more specific. Now, the subclass defines only what's needed to turn the superclass into the subclass. So to think of this in the terms of our program, cash transaction only defines what's needed to turn transaction into a cash transaction. And the same thing goes for charge transaction. It defines only what's needed to turn the general generic transaction into a charge transaction. And that's why the subclass isn't a copy, but it's just an extension of the superclass. Now, multiple inheritance. In Objective-C, every class has just one superclass, but can have an unlimited amount of subclasses. This may sound like an odd limitation, but think about it in this way. Every person only has 2 parents, but can have an unlimited amount of children. But just in Objective-C, you can have, I guess, only 1 parent. But you can have an unlimited amount of children or subclasses. Anyways, some languages do support multiple subclasses, which is called multiple inheritance. And although multiple inheritance isn't supported by Objective-C, it does give us some of the features not found in other languages that give us most of the benefits of multiple inheritance without the disadvantages. Now, what inheritance enables? We've already gone over a little bit about what inheritance enables us to do, but we're going to go a little bit more in the next few slides. It allows various things that make your program more extendable and enhanceable. With the subclass, you can make 3 different changes to what you inherit from the superclass. And the next slides, we'll be going over these 3 types of changes. The first one that we'll be going over is adding new methods and IVARs, and this is one of the most common reasons for creating a subclass. So let's say you have this superclass, and in one situation, some part of your program needs a little bit more functionality. So you can create a subclass with that needed functionality, and then whatever that part of your program that needs that needed functionality uses that subclass, while the rest of the program that doesn't need that extra functionality still works with the superclass. You can also extend the behavior of a method. We do this by adding a new version of the method we're going to extend, but we still use the code in the old method. So you add a new method, and the new method overrides the inherited version, and then we send a message to the new method that we just created with the same name as an old method from the superclass to execute the inherited version. So we have this method that has the same name as a method in the superclass, and we have added some new functionality, but then we also send a message to run the functionality in the method from the superclass. So you're running the original functionality and then the new functionality. So all in all, the inherited functionality will run along with the newly added functionality. And when you see the stuff in code, it makes a whole lot more sense than me explaining this in bullet points on a keynote, obviously. And implementing a method with the same name as an inherited version is known as overriding a method. Now you can also change the behavior of a method. We do this by completely replacing the previous method by overriding it. But this time we don't send a message to run the inherited version. So you're just running the new functionality. And the old methods are still available for any classes that use them. But any class that inherits from your subclasses uses your new method. And overriding methods isn't unusual, but it does make your code hard to follow. And it really makes it hard to follow if you're doing this a lot. And if you are doing this constantly, you really should question the design of your program, because this method over here in this class does this, but the same method over here in that class does that. And you're not just enhancing functionality, you could be completely changing the functionality, and it could be a whole different type of functionality. So depending on how much you're changing, it can really make your program very, very confusing, because like I said, this method over here does this type of functionality, but you're not sure with what class is using it to which functionality is actually being executed. It's just very confusing if you're using this a lot. And a little bit more about changing the behavior of a method. Even if we override a method in a class, subclasses still actually have access to the original method. And obviously this isn't a great idea to use this functionality. And again, you should question the design of your program if you find yourself using this feature often, because not only is it just like this method over here in this class does this thing, while that method in that class does that. It could be this method over here still does that sometimes, but not all the time, and it just becomes very confusing. And if you find yourself using these functionalities a lot, you should really just question the design of your program. And the best way to avoid lots of headaches and a confusing program is just to have a good program design from the very beginning. And changing